Tap to open instant gripper response. Drag the position slider precise movement. Adjust force real-time feedback. In this video, I'll walk you through the complete process of achieving precise gripper control using the P4C5 full-featured development board. From protocol acquisition and system architecture selection to final control implementation. If you're working on robotic arms, grippers, or embedded control systems, this workflow can be directly applied to your project. The target functions are straightforward, mainly divided into 4 parts. Gripper, open, close. Position control. Force control. Real-time command response. Essentially, this is a combination of UI control and low-level communication driving. To control the gripper, the first step isn't writing code, it's obtaining the device communication protocol. In my case, I directly contacted DH Robotics technical support and obtained the complete command specification, including command format, data field definitions, control parameter ranges. Without this step, the entire development process becomes extremely difficult. For the controller, I use the P4C5 full-featured development board from Wireless Tag. The board is based on the ESP32-P4 plus C5 architecture, integrating core computing and communication capabilities, while also handling engineering details like USB, power supply, and power management. Simply put, you can focus on feature development instead of low-level setup. Initially, I chose the official factory firmware with app-based loading for development. The idea was, build the UI and control logic directly on top of the existing system. It sounded reasonable, but in practice, the program kept crashing repeatedly. The root cause was a low-level resource conflict between the factory firmware framework and the gripper control logic. This made it extremely difficult for the application layer to stably interface with the hardware control logic. In short, the approach works in theory, but is unreliable in engineering. So I switched to a different approach, rebuilding the system directly on top of the BSP. Specifically, I did 3 things. Extracted the BSP from the factory firmware, rebuilt a minimal system framework from the ground up, integrated the UI and gripper control logic on the bare framework. The UI was redrawn using LVGL, while the communication layer directly interfaced with the gripper protocol. The advantage of this approach is the entire system becomes fully controllable, with no middleware interference. Here's the final result. Tap to open instant gripper response. Drag the position slider precise movement. Adjust force real-time feedback. Throughout the entire process, no errors, no lag, stable response. If you're working on a similar control project, this solution is fully open source and ready to reuse. Wireless Tag, dedicated to ESP32 development boards.